Now we are live. Now we can actually pretend nothing happened. All right, here we go.
So you may want to scroll to the bottom. That's where I have the API shit.
Someone did not follow the process.
Other people's posts.
Exactly. Now we have history. Just edit the post.
Yeah, that's true. Just do it. So we had discussed writing base64 previously on the writer APIs, and we thought that we wouldn't need it. However, on the serializer, deserializer, byte arrays are commonly encoded and decoded as base64. So we want that behavior regardless. And if the serializer has the behavior, it might as well add the APIs on reader and writer as well. And that's because that's what the serializer leverages. So the proposal is to add both write base64 APIs and get bytes APIs on the reader side. So you get both base64 encoded strings, you return byte arrays, and if you want to write bytes, you write them as base64 encoded strings. Some questions are just around naming, effectively, and the semantics of throwing. So I chose write as base64 string. We could do write bytes as base64 as string. I'm okay with either bytes or base64. Having it be a suffix didn't seem right because that seemed now it didn't follow our existing APIs where we had string as a suffix.
Okay, so let's decouple these two first.
Yeah.
So let's first talk about the writer.
Yeah.
I think the writer makes a lot of sense to me as it's proposed because basically you're saying what you're writing. Then make sure to look at the other APIs that we have on it that nobody else can see, but hey, I am like that. Yeah, so the existing one we already have write boolean, write comment, write null, write number, write start array. So basically the methods are basically what is kind of a token, I guess.
Yeah, what is the JSON format being written?
And then we have overloads with just whatever the shape is that we have. So we have write string with a byte array, a char array.
Yeah. And
then like, I don't know, is there an overloads? And then, so is base64 a thing in JSON? It's not really, right?
No.
It's not a JSON primitive, but it's a common pattern for sending arbitrary data.
Right.
Non-textual data.
Typically, whenever someone passes in a byte array, they expect the data to be base64 encoded.
What does it look like in JSON? It's just a string.
It's a string, which is why I have write as base64 string.
Yeah. So to match whatever I just had up, XML writer, I think we should get rid of the word as. XML writer has write base64, and then something else. So write base64 string matches it intersects what you've been doing with the suffix of whatever the JSON type is with not having an as in the middle of write base64. The prior art.
Okay, I'm fine with that.
Should we have like write string as base64?
So that's what I
because that seems like more logical given the API service of the writer.
Yeah, so for the reader, for XML reader, it's read element content as base64, but the writer doesn't have the as.
Right.
And for your question around having it be suffix, we're not writing a string as base64, we're writing bytes as base64 string. So if you say write string as base64, that doesn't make sense. But the input the user passes in bytes, and we write it as a string.
Okay, replace as with in. My point is more like you're writing a string, which is why it makes sense that the method starts with write string. And then basically the type itself is not indicative enough to just make it an overload. And that's why I just said like you just start with you're writing a string token, so that's why the method is write string, and then you say in base64 or like base64 encoded or whatever that you want to do.
But this isn't necessarily writing a string token, is it?
It is.
Always writing a string token.
Sorry, it's not writing. The input to this isn't necessarily a string. It can be arbitrary bytes.
Yeah, it's literally any bytes. It's a byte array.
Right.
But that's how
I would be confused if this said write string as. I would be confused because then I would think that everything that I was passing as input represented a string.
Right. Exactly.
I'm confused by that because basically when you look at the writer today, we have, for example, write number, which has several overloads. One of them is read-only span of bytes. Some of them is read-only span of char. Some of it is decimal, double, whatever, right? So basically the methods that we have on the writer are named by what they generate in the JSON.
Yes.
Not what they take in terms of inputs.
Right.
That's why I would start with write string and then choose some appropriate suffix, right? I mean, I get that as is not great, but like, let's say in base 64 or something like that.
The only thing is, I was thinking
Or write string base
write
64.
as the operation, as being the prefix, string being the suffix as the JSON literal you're writing, and whatever's in the middle is whatever you want to specify as.
Yeah, I think the important thing, the contextual thing, is you're writing base 64, and then you're writing it as a string. And so if you're going to be looking for it, you're not going to look for a write string.
Right.
You're going to look for a write base 64. And then the string is just contextually telling you we're emitting it as a string token.
So I don't disagree.
But then to Emo's point, the other APIs would all be as number.
Right.
Which
I mean, if it's
class
right,
are they
if it's
on?
right string as base 64, the word as definitely makes me
JSONReader.
think the input is a string,
Right.
and the bytes are going to go.
So
through
what
some
about
kind
write
of
string
token.
in base 64?
If it was just write string base 64, and we had
Yeah.
no linking verb, then that would. It wouldn't obviously be that the string is an input, and it then looks close enough to the rest that it's like, oh, I get this within like a half a second. So, if we think that string needs to be adjacent to write, then I would say write string base 64 with no linking verbs. And if we, but I
prefer
think
write
that
base
what it's
64
doing is
string. Yeah.
it's writing a base 64 string.
Right.
Granted, that's not a JSON primitive, but that's what it's actually writing.
That's what I prefer, but I'm okay with write string base 64. We can flip it.
Yeah, we generally do suffixes, but like yeah, either way works for me. Like all I'm saying is that the given API pattern that we currently have is that the prefix is always the JSON primitive. But I just feel like it's at the end of the day, it's up to the people that use JSON how they think about it. The only thing that we should avoid is that I die because I'm coughing. That would be sad. Remember the one API review that died.
Yes, we would.
We would remember that.
It was too cold in the room.
That's what it is. It's too cold in this room. No, I think that. So the question is: would somebody, when you see base 64, is it clear that it's a string rather that's a byte array, right? And you could say that if you say base 64 string, maybe that's enough, right?
The question would be for the other approach, where you have write string base 64. What does it become for write string value? Where we just have a value. Because currently write base 64 string value is easier to read than write string base 64 value.
Or
Now
write string value base 64.
Yeah.
Sure.
So that might break the tie, and we would just drop the as based on the current proposal.
Yeah, I think it would generally drop the as because that'd be weird. So it would be write string base 64.
No, the other way around.
Or it would be write base 64 string, right?
Yeah.
And then, well, yeah, you just combine them with value or not.
Yeah.
Either one works.
Okay. Parameter names, I chose bytes, not data or byte value, because bytes is what we had on the existing base 64 APIs.
And what else would it be?
I was thinking like maybe data or bytes value to specify its value.
Bytes. We're not interpreting it in any way, shape, or form.
Yeah. Okay, on the reader side, we have get bytes and try get bytes, and the same APIs exist on JSON element. Do we want to say, be more specific and say base 64 encoded bytes? Or is short and sweet get bytes sufficient?
Okay, so the problem is, given that we don't have char8, and that you're working on a thing that says byte, get bytes sounds like it's getting the underlying data stream.
Right. Because you pass in a review span of byte, and now someone can say, give me the bytes.
Yeah. And that is very much, in fact, what you are not doing.
Yes.
So
I'm fine with the more verbose name of get base 64 encoded bytes. But I'll leave the naming to the room.
So to like the convert APIs, we have convert from base 64 bytes. So maybe this should be get bytes from base 64.
Yeah.
I mean, that seems a little long and verbose, but it's also, I think, kind of adequately descriptive.
It's shorter than the get base 64 encoded bytes.
Get base 64 encoded bytes also makes it sound like you're going to get the byte representation of base 64 encoded text, which is
Jesus Christ, yeah, you could, yeah.
right. You could conclude that, and it does the opposite. Right? It decodes base 64.
Yeah.
Yeah, I think the only thing is I think try get bytes is too short, because basically you could imagine that we support anything to be represented as bytes at the end of the day, right? So it's very unclear that this only really is meant to decode base 64.
Sure.
So,
By the way, on the base 64 API that we added, it's decode from UTF-8 and encode to UTF-8.
yes, but base 64 was the type name. Like it's present.
On the convert class, we call it from base 64 string.
Yeah,
That's what he doesn't mention that.
yeah. I call that API like 14 times a day.
You don't call the UTF-8 one? Okay. All right.
So you're the pro problem then.
Do we want to expose the base 64 formatting options as a parameter?
You're not allowed to have new lines. Or I mean, you can write a backslash in it or R in. It just doesn't really matter.
Okay.
We can't actually put a new line. Yeah, I would suggest get bytes from base 64.
Get
The
bytes
from indicates that
base
there's a
64.
decoding. The base 64 says what the encoding was, and because the data type is implicit from the context.
Okay. I'm fine with that. Also, the parameter name value is consistent with the existing APIs, or should we call it bytes?
Try is usually out value.
Yeah.
So try get base 64 bytes.
Try get bytes from base 64.
Should we have it from base 64 string?
There's no string. String is a type that has a length. It is a length prepended and null appended UTF-16 LE encoded value managed by the CLR. This is bytes that it already knows how to interpret. There's no string.
Sounds good to me. One thing to mention is that while writing, we will escape the base 64, so that if you had a plus, it would get escaped. And that follows the existing coded APIs.
So we said try get bytes from base 64, right?
Yeah.
Isn't there still a string because the JSON spec defines a string, and so you're reading a token which is a string?
Fair enough. I mean, I guess that's true. The data, the token type has to be string for this to see.
Yes.
So there is a string. It's just the other kind of string.
Do we care at that point though, because we don't have it anywhere else?
But I think from base 64, I don't know that adding the word string on the end.
Yeah, I prefer not adding the string because for the get string APIs, we add string to mean .NET string, not JSON string.
So what does try get in 64 do when the current token type is string? We don't decode the string into
It has to be a number. And it has to fit.
So all the other ones are effectively tied to the token type.
Yeah, everything's tied to the token.
In that case, I agree with Tanner. Like that seems, because otherwise it seems, because on the writer you basically say the meta primitive is called base 64
Yeah,
string.
but we don't say try get UN64 number. We are specifying the .NET type.
Fair enough. In that case, I take it.
Right. But if we did ever want to expand that in the future to support decoding strings, because it's a fairly common operation for some types, then how are we going to differentiate?
I don't think we would. We would just say, like, making more scenarios work is generally not a breaking change. You would just say, today we just threw off the token type is not number. Now we would say, if the token type is string, let's try to parse it and then give you that thing back.
Well, isn't it breaking if the person doesn't, if you've got someone who doesn't want to support anything but a number and someone who wants to support both numbers and strings?
That could be a reader option too, or some other extensibility one.
Okay.
One thing is,
Maybe.
I end up throwing invalid operation. If the base 64 string was invalid, should we throw format exception?
What does convert do?
I don't remember.
What does the non-try version of base 64 do?
What do you mean?
Well, we have the UTF-8 base 64 type.
Oh, they return operations type.
It
They
doesn't.
don't throw.
It doesn't have the throwy kind.
No.
It throws a format exception.
The throwing kind.
Basic,
Yeah,
convert
from
base 64? Okay.
from base 64.
That's more consistent with the other APIs we have, like try get UN32 and stuff. They all throw format exception, so I'm fine with that.
So I will say it just so it gets said. Christoph would want to span write E1. The problem is the try becomes ambiguous. So that's why we can't. Okay, it's been said.
So
So,
that
I
was
mean-
a bit fast for me. Why do you think we can't do span?
Because try get bytes from base 64 that writes to a span would now need to return false of this doesn't look like base 64. Wait, when are you returning false in the try?
If it's
Oh, sorry, get bytes is throwing format exception. Yeah, so try get bytes that could write to a span. Is it returning false because the content isn't base 64, or is it returning false because the span's too short? Because you can't tell the difference, it's not suitable for a try API, and we have no span APIs or we have no way of predicting the links.
I mean, we have the whole
can't.
value span, value sequence property if somebody wants to write their own custom. Like this is effectively
That's true.
I mean, we have a basic 64 decoder for span, right?
Yes.
So you would just pull the
the
raw
user,
data.
the user just grabs the value span,
Yeah.
passes it into the or
Well, they-
escapes and
They need to de-escape.
yeah, exactly.
And
But we
just
have an
not-
API on
Yeah.
on base 64 that takes a
You
UTF-8
could
encoded
also expose it as a try API that has a second out parameter which says how many remaining characters are there to be written, if any, which is
Maybe.
how native APIs do this.
I say we've
So
I believe we
problem
have
is if you
never
also
done
give it
that.
a larger span, like the span is much larger than the thing, like you have to know where it ends.
Right. So you would
Right.
have you would have the
Yeah,
8
right.
bytes written anyway. So that is also overlooked. So.
Yeah. You could do it that way if you choose to, but like I don't know if it's worth it. We can always add it later on.
So what do you mean by encoding though? So the way the span gives you the quotes around the string.
No, so you have to unescape the thing before passing it to the base 64 encoder.
That's what I mean. What escaping are you talking about?
Somebody could write every single character in the base 64 as /u and then the ASCII value. Particularly if it was whatever 3-byte sequence I gave you that we will write down as escaped pluses because we don't write pluses without
Do we
escape.
have a span-based API to do the decoding?
To do the unescaping,
Yeah.
yeah, we had it. We are adding it in the web encoders APIs.
So if Christopher really wants it, it's just 10 lines of code for him, or is it like 100 lines?
No,
of
it'll
like,
probably be like 10 lines of code.
yeah. Okay.
Are we just going to be calling convert to do the conversions here?
No, we call it base 64 API. The operator has space ones.
What namespace is that in?
System buffers text.
Okay.
Because we don't want to call the string based APIs, right? That's string based. We won't call the UTF-8 based ones.
Well, we have a read-only span one for to, but not for from. In convert.
The fact that you know system buffers text top of your head is kind of scary.
But look, I implemented it yesterday.
Yeah.
I guess that's true.
And I always feel like we are missing the one on convert that writes to a span, and then I find it. It's just named weird. It's there.
Okay.
Like when I give up and I write it another way, I then come across it.
All right.
Oh, try from.
Yeah, try from. From's the verb.
All right. This one is done.
Sweet.
Oh, that one has bytes written.
You may want to go to the other one because that has both of them. Scroll to the bottom. Yeah.
Scrolling.
So I provided the existing APIs and the ones that we want to add so that it's easier to just see what we're trying to do. So the objective here is if the user has a reader or a writer, there's no way for us to go and serialize an object from the reader or writer. Today the user would have to either pass the reader to a JSON document to create a JSON document, and then do some other work. Yeah, and then get the string out of that and pass that to the serializer, which is double the work. Similarly, on the writer, the user would have to write to an array and then pass that to the serializer to serialize. Here, we just take in the reader and writer directly so that the user doesn't have to go through this double work or round tripping.
And these cases are exceedingly common when writing converters.
Right.
Because you're given a reader or writer, and you might need to recursively call into the serializer to do work.
Right. Effectively, this is aside from the converters, which is a hard requirement. The use case today is also based on performance, which is these APIs will end up resulting in faster for people like Signal. So we have the existing APIs. We have overloads for parse that takes a span of byte string, and we have two for writing is 2 bytes to string and write async. One of them takes the object, the other takes the return type. So we follow the same thing here. We have 2 overloads on read value. One takes a reader and a return type, and the other is a generic. Similarly, we have write as value overloads and write as property overloads, and these match the existing JSON document and JSON element APIs. So the few questions. One is parameter ordering. In the case of the output sync for writing, the stream and the writer is not the first parameter, but for the input source, i.e. the stream or the reader, is the first parameter. Should we be consistent across the board or leave it the way it is?
So with data contract serializer, stream thing is always the first parameter.
Both for read and write?
Yep. But I think that we're very
yeah, I don't know.
all across the board
Yeah.
on these things.
Yeah, so that's the output. So the output case we have it in the middle, but in the input case we have it in the beginning.
XML serializer has a verb serialize that has 1, 2, 3, 4, 5, 6, 7, 8 overloads that take the stream first and one that takes it second. And then it's deserialized always has the stream.
What's your concern? Like, it's just the ordering is inconsistent.
Yeah.
Should we fix it now?
Or is it okay for, because you're reading from the source and then writing into an object, maybe it's fine to have the reader be first. In the right case, we're writing to output sync, but the most important thing is the object that we're writing. So maybe the ordering is fine. It was a concern that was brought up, and I think we probably should settle on it.
It's really the problem with statics, right? You get instance members, it gets pretty obvious.
You on the call?
Yeah, I mean, originally, I think that the thinking was that object and the optional type parameter are more important, more pertinent than the stream or pipe writer or whatever, kind of async thing you're going to write to. So that's why they're first, and why they're not first on the other one is just because they physically don't exist, because that's the return value, of course, on the parse, on the read async methods or whatever. But I can see a value making it consistent with stream first, mostly in the case of if we ever wanted to have this to be an extension method on that first parameter.
Right. I mean, as a precedence, JSON.NET has both read and write being the first parameter.
I would expect the API to have the writer always at first, because it's effectively an extension method. We're just not exposing this. And if you were doing like exposing this as a C API wrapper, that's the way you would likely do it.
And the same would apply to the stream overloads that we have.
Yeah.
Where the stream would be the first. Okay. One thing though is to try to avoid breaking changes. I may not do this change for preview 6, so we will be inconsistent in these APIs, and then going forward, I'll just update them. So it's a bit late to. Yeah. In terms of naming, I chose read value to match JSON documents parse value.
I don't know if we're allowed to make breaking changes after preview 6.
I mean, JSON has exception.
Adding new API exception. I don't know if you have a breaking API exception because we're going to let people have a.
No, because we also have a UX study, which most likely we have API changes that fall through.
Just making sure that
Yeah.
that you
I mean,
are.
if it really is a problem, we can do it now and observe it. We just need to.
Right. My only concern is that there's multiple teams, and if we break them now,
It would
the day before-
likely need to go through QB mode if we do it in Preview 6.
Yeah.
So people would be unhappy about that if we
right.
have an alternative.
I mean, we're already doing some breaking changes. For example, we are making the serialization namespace change. So it's probably okay as well, but I just wanted to try to reduce the number of code changes people have to do. Namespace changes is somewhat easy to make.
Well, maybe.
Relatively speaking, I'm going through all the uses of these APIs and updating them.
Yeah, the problem is usually not how hard the change is. The problem is just more how many teams have to accommodate change, and how hard is it to schedule the change. Right?
Okay, so the other question was around read value as a name versus just read. We have read async that takes a string that reads as much as possible from the string. The read value case here, the reason why it's read value is because it's only going to read the next token, whether it be a start object and it reads till the end of the start object or start array, or if it's a primitive, all in the same semantic of JSON document or parse value, which is why I have the value suffix there.
So the existing ones parse the entire input, right?
Yes.
I would agree with that. And we generally said parse is for string and read is for
Streams or
something else. Yeah.
And the third question is around should we have just write and a write API, or is it okay to follow the JSON document business and have write as value and write as property? The main reason behind this is the user today does not have an API on the writer to write just the property name. So this will be the only way for them to do so, and this is how the JSON document APIs look as well. So I just follow suit. Now, if and once we were to add write property name API, we could just add a write overload that takes the writer and writes the type, and the user has to call the write property name API on the writer before calling this API.
Did you investigate that more?
I do not know.
Okay.
Yeah, I was finishing up these things, but
Okay.
that's still pending.
Yeah.
What was the third thing? I was just typing notes.
We have write as value and write as property because we don't have mainly for perf, and also we don't have a writer API that lets the user just write a property name.
I've got it. And you mean the investigation was for perf?
It was for perf and feasibility. Yeah, perfectly.
Why write as? It looks like all the other reader or the other writer APIs are just write property.
This is following JSON document write as APIs. JSON element has write as property and write as value.
Okay, but the writer generally doesn't.
Yeah.
What it looks like.
It seems inconsistent with like the existing ID.
Well, those are, you have the object and it does everything it wants in the object, and this is telling you how it's going to interact with the writer that you have. So I do like the as there as a level of indirection. It's telling you how it's going to compose things instead of.
Why is it useful? What does write as property convey that write property would not?
I mean, really, it's that the as for value is useful, as opposed to write. You know, JSON. You call JSONSerializer.write value. And of course, I'm writing a value. It's what I'm writing. It's like, no, you're writing it in the payload as a value instead of as a property.
Maybe my brain just, to me, as is always like the conversion is going on somewhere, which I don't understand.
I mean,
But,
if we
yeah.
want to get rid of the as here, then we would get rid of it in JSON element as well.
Yeah, it looks like out of all the write APIs we have between both the writer and the element's the only one that uses as, and it's only got 3 of them.
Yeah.
And then the writer has a bunch of them, like write property indented and all kinds of stuff like that, and it never uses as. So, especially with these using the writer, and if we're going to change it to make the writer be the first element, and if they were ever extension methods, then no as would be the most consistent.
So we say write value, write property then?
One thing to note.
And push on the pending breaking changes stack to rename the ones on JSON element.
Yes. I don't want to do that. Yeah, exactly.
I mentioned it in the comments that we should also do this in JSON element.
One thing just to note is that these APIs take JSON-Serializer options, and whenever there's a disagreement between the JSON-Serializer options and the options that are passed in from the reader or writer, the reader-writer options are honored, and not the JSON-Serializer options.
Why is the reader writer win? It seems like, at least logically, the normal case is that parameters passed in outweigh existing state in an object.
But reader is also a parameter. So the user constructed a reader and passes it in, and because now they have a serializer options.
Because they're construction options for the reader and the writer, but you've already constructed them, so they don't matter.
Yeah, I mean, logically, what you want to do is you want to say the setting that is most local wins, right?
Right.
If you basically if you think of the serializer options as like global options, and you think of the writer as the thing that you instantiated afterwards, it is more local than the global options.
Yeah.
And you pass both in as arguments, so you have to have some sort of sane tie breaking. But like, what else would you do if you wouldn't honor the reader-writer settings? Because that's the thing you're reading from or writing to, right?
Yeah. I mean, alternatively, we would construct a new reader or writer from the JSON-Serializer options, and now that just defeats the purpose of why we're taking a reader.
Yeah.
So why are we taking options at all then?
This is meant primarily for converters, because generally converters, the user passed in a serializer options to a serializer, and they have a custom converter, so the converter would need these options so that they can pass through again.
I guess it's confusing how the serializer options and the reader options interact with each other.
So all the reader options that are, all the options that are duplicated between the reader options and serializer options, the reader wins. Everything else, the serializer option follow.
I mean, alternatively, we split the serializer options type into two. Okay.
Normally, the reader that's passed in is going to be obtained from a callback from within the converter, so it's going to be the same reader that was instantiated with the original options anyway, at least in the extensibility converter model. So it's normally not an issue.
I understand that it's normally not an issue. I'm just saying, like, conceptually, I find it at least initially confusing that you would have serializer options and reader options overlap with each other, and
I hate this one.
have some of them win out over the other. Like, there's a weird union there that you wouldn't initially think of.
That is a concern, yes. Ryan or Steve, do you have anything about that? The fact that the serializer options has a union of options with the reader and writer options, and
I don't understand what the alternative would be.
Right.
Yeah,
Like the serializer needs to give you control over the reader and writer options.
Right. I'm not sure I've got a good alternative. I'm just saying it's something that coming into this without having talked to the people who wrote it originally, it's probably going to be something that might be initially confusing or a pain point until people do understand it, and then they'll come to rationalize.
Docs should just say, the JSON serializer options, max depth, and whatever the other 2 or 3 are that invert or build the reader and writer are not respected by. Talk about done.
If you scroll down, there's one more nit is that the JSON element has the write as property APIs, but it doesn't take JSON encoded text as an overload. So I'll just add that too, because we added it after the fact.
Which one is that?
Last method, it's under add.
Yeah, sure. Get missed.
I mean, when we added these, we didn't have JSON encoded text. And then when going through the JSON encoded text, APIs, I missed some of them.
Because I remember that I left off string. Meeting away both ways.
Yes.
And then, yeah.
Okay.
All right, let me just quickly paste the stuff in, and then you guys can read it over to make sure that I capture the thing accurately.
Probably the first word you want to say read and write also. Be the first argument, not just read.
So what do you want to say? Do you want to say the reader writer is the first one?
Yeah,
Make the
stream,
stream,
reader,
reader.
and writer. All of
Yeah.
them should be the first.
Oh,
Yeah, I mean, that's stream with a lowercase s, so I was using that to mean any sort of ready, writey thingy when I was talking about the other serializers.
so like that.
Yes.
So I encoded the whole thing as a type. So the type is called stream, reader, writer
Without commas in fact.
dash thingy.
Okay. We're making good time.
So
I'm
dash
editing
thingy. There you go. All right. So let me just mess with the labels. Okay. So.
And then you can by default approve the other one as well because that's reader. I just combined them.
You mean this guy here?
Yes.
Right. Just happened. Really confused by the amount of tabs that I have. Two screens of the same information is actually not useful. Okay, that's the one I wanted. All right. All right, so close, close. Here we go.
Okay. So the serializer supports all .NET types effectively. Like we have char, bytes, use s byte, use short. But the reader writer do not provide APIs that let you get byte, get s byte, etc. So we have get int32, get int64, get string, etc. Similarly on the writer we have write int32 and 64, but not the smaller numeric types and not char. So the proposal is to add all of them on the reader and writer. Get byte, get s byte, get int16, get uint16, and the try version of those, and also get char.
So I understand that it's a consistency argument, but is anybody asking for them, or is it just we saw them and like, well, we probably should have them?
So effectively, the user, the serializer and deserializer ends up doing workarounds for this when these types are not special. I don't see a reason why the serializer and deserializer should have to work around it by adding their own length checks and their own validation.
Well, the same question for the serializer. Is it just because we walk these types because they happen to be there, or do we actually think people put them in their details?
I mean, people put these types in there, and they are .NET primitive .NET types. If you don't add support for these, it would be really hard.
Yeah, anyone who's wanting to like serialize or read or write a field or a property which was a byte is going to have to manually do checks.
Really a lot of byte properties.
Yeah,
It depends on if
It's
you're
not-
doing performance-oriented code or not. Maybe.
Single byte properties?
yeah.
It's not common, but it's very surprising if they're not supported.
Right.
I would agree with that.
The serializer, for example, will have to check, byte is within the range. Same for S byte and S short. And the car one is particularly more difficult to work around because allocations and performance and things like that. So.
I mean, I would also
slow it
say
down.
I would also
Scroll
say
down.
that it's not necessarily critical that we
thought
make
you
the
meant the
perf of
volume.
serializing a character be good.
So I would honestly advocate that the serializer should not support serializing the type char because it cannot represent the full range of char and it can't write an unpaired surrogate and it can't read an unpaired surrogate. So it's actually not doing what it says it's doing.
Should it probably be rune, since that's going to be our new primitive type for that anyways?
I have no problem with supporting rune. I'm saying it shouldn't support char.
Right, as I was saying, instead of char, should it be rune?
It goes back to like Ryan's point though. What do people usually serialize, right? Probably not those characters, right? For the most part, if you would serialize a char, it would serialize something that would fall in the range of what you would expect, right?
I mean, for me though, this is relatively low-hanging fruit. And it's about polish and completion.
Yeah.
It just seems surprising if we don't support it.
Yeah, so the only reason I'm asking is like I have no idea what the cost is, right? The problem is like, we had this discussion many times of like, oh, should we support decimals? Like, oh, okay, that's because complicated. We don't know exactly what the policy should be, right? And all I'm saying is that if your argument is we should support the inbox types, well, that is a sizable set.
Yeah.
And then the question is like, is there like at some point there's like this, we have the type, but nobody ever calls them kind of situation, right? And then like
So,
I don't have a problem with them per se. It's just
The category of things we support are numeric types.
yeah.
Having them, like we have int, int64, uint64. We chose those. It seemed arbitrary to just skip these ones. These
So
are
there's work on the team either way, because if they're not going to support like byte, we need to throw.
I think there's also a difference between any
Fair
inbox
enough.
type and the primitive types, and potentially even between the primitive CLS compliant and primitive non-CLS compliant type.
Nobody cares about CLS.
I know no one does, but
That's not true. One guy logged in a shoot.
I think the
on
the
HPNet.
keyword types
He was
Yeah,
really
right,
adamant
are
about it.
probably the important set to support.
I wouldn't say keyword types. I would say CLR primitive types, because decimal is still one of those questionable ones.
Yeah, but I think this goes back to like I think Jeremy has a point. If you make a poll on the street what people consider primitive types, it basically boils down to that.
Yeah.
Like a rando type that has no keyword support, well, that's a type, but like I don't care. But things that have C# keywords, like it's always surprising people to learn that decimal is not a primitive type. It's like, what do you mean? Like it's primitive. No, it's not.
It starts with a lowercase letter. It's going to be a primitive.
So one of the questions is like, it makes sense to add them on the reader,
Right.
but on the writer, the byte byte short would just implicitly cast to int anyway. The only difference is we have previously had the stance that whatever the reader can read, the writer should be able to write, and vice versa. So for completion, it doesn't.
I think the writer gets it. Doesn't need it.
Okay.
Well, wouldn't you?
If you have a short, then JSONWriter.write number, you pass in the short, it will compile. We'll convert it to an int, but it will compile.
The only difference is the int writer UTF-8 format is slightly slower than the smaller value ones. So if you were to do a direct format, the smaller numeric values, it'll be faster than.
So if somebody found a scenario where these things were really important, we could add them.
Well, and then Jan would say, but how much did you blow your cache alignment by adding more instructions by having another method?
Right.
I
mean,
any perf measurement, any perf gain you would have gotten from having the right byte, you would have lost by having right byte.
my only pushback is so far we've had parity with what reader can read and writer can write. That's the only reason why I have them.
So honestly, my opinion is we should maintain the parity and not do any of this.
Well, so
No, like
the implicit conversion is not true for F#, where you don't have implicit conversions and where you're going to have a byte overload for them to write
There you go.
their bytes.
So-
for a single byte.
Yeah, if you have a byte and
What
you want to write,
about a 16-bit integer? Does their version of short convert to int?
they have 0 implicit conversion,
That
and
is
they've
false.
got for their primitive types they do not have implicit conversion. And they have literal support for both byte, sbyte, short, and ushort literals.
Right,
So-
but like most of the places in the framework, we only take an int. We take a long and an int when we think both are suitable, or someone yelled at us that they wanted a long. And we rarely take short anywhere.
except for the conversion APIs and readers and writers, such as binary stream
Well,
and places like that.
Because binary stream read short is only advanced at 2 bytes. Like that one has there's a side effect of calling the wrong one, of it read too much data.
I don't see that much of this being costly, and I think it's part of polish. I don't see it hurts us in any way.
I mean, every method we add is another
Yeah, personally, like
annoying place we have to maintain. But
I think Ryan's argument still holds. Like, what's the least surprising thing, right? And like, I think the naming is consistent with what we have.
Yeah.
I agree with the parity between reader and writers. I would not allow implicit conversions, especially because of other languages. And other languages really means F sharp.
Yeah.
Because there's really not anything else.
So, question for try get char. What should the semantics be? Should we return false or throw if it's not, if the JSON?
So try get char is kind of an interesting one to Jeremy's point, right? Like if char is not all char values are representable.
Right. If it's a surrogate pair, what happens? If it's not a single character, what happens?
A surrogate pair is not a char.
it would be a surrogate.
It is a string. You can only have a surrogate, and you can read and write surrogates. So,
But we can't read a surrogate.
why can't you read a surrogate as a character? It's invalid to have a string which has a single surrogate, but it's completely valid to have a character which is a
Right.
single
So that's my question, right?
Because the payload for these types is UTF-8. There are no surrogates in UTF-8. It's a UTF-16 specific concept. It literally cannot be encoded.
I mean, you could also just say if we felt like it's really important, we could say that we encode characters as integers.
I mean, bottom line, somebody has a car property on their Poco object, right? In
Saying
how do
char
we
is
support-
treated as short, or U short,
Yeah.
is actually probably the best answer.
I wonder if that's what JSON.NET does. Let me wake up James and ask him.
So question around what
It's
is
currently like 5 a.m.
So what does the write actually do? It writes a single string with
a single character? Yeah, a string code character code.
Or quote /u
Yeah.
as soon as it's outside the range of things
Right.
that we're willing
So
to write
again,
down.
similarly on the
Yeah.
read side, the right side, what is the semantics of write string value? Is it a single character with in a JSON string with quotes around it, or and what happens if the char contains a surrogate pair?
I would I think there's two options. You can either do
Just a surrogate, yes.
what Jeremy said. You just treat it as a short. You just encode it, escape it, and then
The concern would be that
or you just throw when you actually do that.
if the user says write string value and pass it in a surrogate character, and then they call get string on the data they've written, get string would fail because you have a surrogate character only. It's an invalid .NET string.
Yeah, that's what I'm saying. You can either say, yep, you asked for that, or you just throw when you detect that.
Because I think write string will throw. We'll throw and say that this string was illegal and we can't represent it on the wire.
In that case, we should throw for
Write string would throw.
Write string, I believe, throws if you give it an unpaired surrogate.
Yeah, but I'm saying if somebody wrote write string value with a character.
No, but he's basically saying if write string throws, write char should probably also throw. Like, why would it not?
Yeah, write string value with a char with a value where char dot is surrogate is true should throw. Well, I don't know how to write this.
Okay.
You said write string. This isn't a string.
Right.
If you but
If
write
someone,
number could take a char overload of like, yep, I'll totally write this char down as a number. It's a U short.
I'm gonna bet that something like I'm gonna bet that JSON.NET like has both of these behaviors, and it probably falls back from one to the other. I'm gonna ask James about this later.
so question about try get char. If the JSON string is not a single character, should we throw? Or should we return the first character?
On which one?
The try get char.
Cool. Oh, try get char.
Yeah.
So it depends.
True
Like
false.
if we're going to read the first rune and if it fits in a single char. Sorry, if we're going to read a rune and if it was only one rune and then we're going to return it if it fits inside one UTF-16 code unit.
Yeah.
Then it would just fail if the return false if the string's too long because it's like good. This doesn't look like a char.
Okay.
I'd like to get James's input before we make any like final decisions on this.
Okay.
I don't know. Did you talk to him about it?
I'm not talking about.
I would try to get. I think we should try to get his input on this as well. I think that treating character as an integer instead of treating it as a one character string just raises far fewer questions about how it's actually going to behave. And if the reason why we have this is so that we can define the serialization behavior, that seems like that might be a reasonable way to define the serialization behavior.
Okay.
So,
Same as it is a string.
Hmm?
At least JTokenWriter
okay.
writing a char calls value to string.
Yeah, JSON.NET by default will treat it as a string when you're writing. I'm not sure if it allows integer on the way in for deserialization.
But I do agree that treating it as a number is the only honest representation we have since we're using UTF-8 as our transport.
Okay. So the other question I had was around write string value where we take a byte that's a UTF-8 code unit. Is that not appropriate because UTF-8 usually has variable length and it could be 1 to 4, where 2 character pairs for char is not is less common. Like writing a string value where the user passes in 1 byte UTF-8 code unit.
So just any malformed UTF-8 string. Because like you have write string that takes read-only span of byte that we call UTF-8. So
right.
we already have that. Like you can have an illegal string. Either you're currently throwing or you're not.
The question is, like, right now we have an API that says write number takes a byte.
Yeah.
Should we have a write string which takes a byte and treats that byte as string and wraps it in quotes? Okay.
If we had char 8, then char 8 would be reasonable. But I really don't think that we should put byte here as char 8 because
sounds good.
That really is it's easy enough to make a span of 1 and then call it the span 1.
So following up with James would be around the semantics of the API and what it does. I don't think that affects the API shape though. Correct?
Well, the only thing that it might affect us is if we believe we can't define same behavior, it would just not have the API. But I think
at least
if we
for
would,
the char one.
Yeah, I think if we would have, I mean, the question is if we say we write chars as numbers effectively, then well, that would be very weird to call it then, write. You basically would call the API then write number with a char.
Yeah, we
right?
would just overload it.
But I think that seems less valuable because the user can just cast a char to a ushort and pass it to the existing ushort API.
Which again goes back to maybe we don't have the API, right? So like I think the outcome might, change the API shape and whether they have the API to begin with.
So by default, if you pass in a surrogate character to JSON convert, it emits a string, which is a question mark.
Replacement character, yeah.
Yep.
Cool beans. So I want to get James's opinion because he's got a lot of experience with supporting actual users using JSON.NET, and so he'll either say, yeah, this has never come up, like I did this because it seemed like the right thing to do, and what to do for these invalid cases has honestly never come up, or he'll say, yeah, this took me a while to figure it out, and I think this is the right behavior, or he'll say, yeah, I really wish that I had done this differently.
Right. I mean, the requirement is coming down from serializing a char in a POCO. Right?
Yeah, I mean, I think the goal here should be let's try to have an unsurprising behavior for what happens if you happen to do this with the serializer.
I like that. I think that makes a lot of sense to me.
Okay, I have to go to my next important one.
So basically, the thing I wrote down right now is that char is problematic. I think that you made just the case that for byte that might be similar, right? Or what was that?
No, that was different.
Byte,
Okay.
we have the easy number. It's I'm
I was thinking,
saying
like,
we
taking a
shouldn't
byte
also
is
add the byte is pretending to be char 8 here.
Right. Well, and if we're going to serialize rune, that's going to have to be serialized as number as well, right?
Isn't rune a struct?
A rune is always mappable to a valid rune, which means it always has a legal UTF-8 encoding.
Okay.
So it's a string.
But not as a single character, right? It would be potentially multiple ones.
Depends on what you mean by character. It might be multiple code points. It would probably get written down as an escaped UCS2 pair, because that would be the shorter representation of something in the higher value.
Let me rephrase. If I call read string, what would length return?
1.
Always 1?
Oh, it could return 2, depending on where your
that's what I
character came
meant.
from. Yeah. Right, because read string gives you back chars. Yes.
Right. All right, so then let me paste this node in. I think the only controversial one was
The char structure.
char one.
Yep.
The other ones seem fine. I will mark the API as needs work
Yep.
and bounce it back to you.
Sounds good.
All right, and we are done with this one. All right, thanks people online.